Hello, greetings. I'm your Math 410-105 Elementary Algebra Plus instructor. So my name is Gloria Guerra, Dr. Guerra. So welcome. And I'm creating this Zoom video, which will soon turn into a YouTube video of me going over the test number 1 review, the short version that has 25 problems. And that way it might help you or someone study as they get ready for the test. And so the test will be very similar to this review, except the problems will change. And in order to get full credit for your work, you have to show your work to support results. Otherwise, points are deducted if students are not able to show their work. And oftentimes we will guide you. You'll be guided on the test review. You'll be guided with directions and things like that sometimes to help you with showing your work. But work should reflect what you've seen in your instructor's YouTube video. So remember, for an online course, ideally the idea of a student being an online course and studying, they should be seeing their instructor's YouTube video for that lesson. And that's your teacher going over the lesson's workbook, guided workbook problems. And then you would tackle the Hawks Learn for at least 15 minutes, and then the practice problems, and then the certified problems. And you want to be turning in your work from the certified problems that are earned from that certificate. And that's what I usually spot check that work. When you take your Canvas Respondus test, you want to remember that I need that acceptable sitting position. So remember that I need to see you writing on your desktop. So like right now, the way I'm sitting isn't acceptable because you can't see what's going on at the bottom at my desktop. Now my computer though is elevated on a couple of books, so that's why I'm not able to show you. But if I were to lower my computer, you want to have that view of you writing on your desktop area. So not just your face, not just your top of your hands. I've got to see you writing on your paper. So just remember that acceptable view that's required. And so you want to move your camera and set up your computer and everything so that's set up that way. And then after you would complete your Canvas Respondus test, remember during your environment check also, when you do your environment check, you want to show yourself putting your phone into a backpack or a zipper bag and putting that aside. That's very important. Also in the environment check, the photo ID, remember you want to hold your photo ID for about 5 to 8 seconds very close to the camera so I can see that. And then once you submit your tests in Hawks, you close that window and you close the Canvas quiz window, you submit that, then you have 15 minutes to turn in your work as a PDF. And so you have 1 hour to troubleshoot, but your instructor will not grade anything that gets turned in later than 1 hour. So it's the student's responsibility to remember to turn in their work. Otherwise, no work equals no full credit. And so you want to make sure that once you upload or submit your work, make sure that you go to your modules link in your Canvas course and you click on the assignment and you double check your blue link, you double check your PDF to actually see your pages of work from your computer, just to verify that all your pages are there. So you want to immediately double check that from your computer. If you're turning in a quiz, your quiz work goes into the Math 105 Canvas course. If you're taking a test or a final exam, your work, your PDF work goes into your Math 410 Canvas course, okay? All the tests, Canvas Respondus tests and quizzes, they all require that you launch Respondus, and they're all taken from the Math 410 class. So the Math 410 Canvas course. So they all get launched with Respondus and from the quizzes link that's in the Math 410 course. But as far as turning in your work, the quizzes go into Math 105, and then the tests go into Math 410 Canvas course, okay? And then they all have some type of review. So the quizzes have a review that's in the guided notebook. You have a version A, version B, and there's also an online review that you can do. You can use that while you're completing the quiz to jog your memory, and you can check your work, okay? And that PDF would go get uploaded first before you start your quiz. And then also the tests have some type of a review, like this one, for example, the short version available. There's also another version online, and you would just show your work on your own paper. But you can work the review. You can use that while you're taking the completed, while you're completing the Canvas Respondents test to jog your memory, and that will help you. That will be fine. And that also is worth 5 points bonus for studying ahead of time. Okay. All right, so let's get started. So I'm going to just window here so that you don't need to see me the entire time anymore. I'm going to just go over these problems here. So see how I have printed the short version of the quiz review. And what I went ahead and did is I went ahead and printed the template for showing the work. I thought that would be maybe helpful also if I show the work on the template or just refer to that. This is what I'll do is just kind of refer that. But this says test number 1, but this I'm going to also refer to as like test review. It could be for a test review to show your work on. But I'm actually going to show you work here, but just kind of reference how similar that is to the test template for actually showing your work. And it says 80 minutes, but I'm actually going to give you 100 minutes to work on your test. So there's a little error on that. Okay. But if you look at the first problem, it says select the symbol from the set less than, greater, or equal to that can be placed in the blank to make a true statement. Show work using either A, long division, or cross products, or this should be LCD, not LCE, LCD, least common denominator, and equivalent fractions. Okay, so if I show you the first version using long division, the top number is the numerator goes inside the house. So if I were to show long division, I want to do something like that. 4 divided by 3, 4 divided by 3. And I know it's a negative, but I'm going to leave a negative off for now. I'm going to add a decimal and a 0. So 3 goes into 4 one time. 3 times 1 is 3. 4 minus 3 is 1. Bring down this 0 here. And 3 goes into 10 3 times. 3 times 3 is 9. And 10 minus 9 is 1. Okay. And then I'm going to add another 0 and bring that down. And I'm going to start saying, hey, that looks like that repeats because 3 goes into 10 3 times. 3 times 3 is 9. 10 minus 9 is 1. And I say, well, hey, that's repeating. So that's going to be a negative 1.33. Okay. Over here, 2 divided by 5. So 2 divided by 5. So the numerator goes inside the house. This is the numerator. This is the denominator. Numerator goes inside the house. So I'm going to add a decimal and add a 0 here. And 5 doesn't go into 2. Okay. But 5 goes into 20 about 4 times because 5 times 4 is 20. And hey, that terminates. That's a terminating. And so it's going to be a negative 4. Okay. And so if we were to kind of plot these to see where that was at, where are those at? So let's say here's 0. Say here's negative 1, negative 2, negative 3, negative 4. So negative 1.33. Let's say this is about negative 1.5 here. Okay. So negative 1.33 is maybe about somewhere in this space here. That's about negative 1.33. And then as you move further out, negative 4 is over here. Okay. So on the negative side of the number line, the farther you go out, then the smaller you are. So this is actually smaller. And this negative 1.33, that's actually going to be larger. Okay, so the farther you go out on the negative side of the number line, the smaller it is. The closer the negative number is to 0, then the larger it is. Okay. So now when I look at this negative 4/3 is represented by negative 1.33. And so that means that this is larger. This is larger. So the symbol for larger, if you look at your symbol, this is equal to, this is less than, this is the symbol for greater than. So this negative 1.33, this is greater than this negative 4. Okay, so that would be the symbol for that. And I think I have an answer key. If I look at my answer key, let's see. Bear with me because I thought answer key here. Let's see. Bear with me for a second, just a second. So oh, I know. I'm sorry. I know what happened. So I was like, where is my error? Because I found the answer key. And so I double checked and it shows less than. And I'm like, why is that wrong? But I left off my decimal. So you see this decimal, this is not -4, this is negative 0.4. So what helps is, really what I should have done here was if I had put that 0 there, I wouldn't have gone, and that's how people make mistakes, right? If I had put that 0 there, I would have seen that and said, that's not -4, that's actually negative 0.4, okay? So then this actually doesn't get put here. It's -4. Negative 0.04 is actually way over here. So let me take this off. So so this is not -4. So let me just take this off. It's not what we're comparing. We're working with the negative 1.33. And that's why it's good to have whiteout. We're not using pencils, so whiteout is good. And negative 0.4 will be somewhere way over here. So here would be about negative 0.5, right? Negative 0.5. So negative 0.4 is going to be about maybe, and now I can put, remember how I didn't have the little negative signs? And I know I have them here, but maybe now would be a good place to insert them there. But maybe negative 0.4 would be about maybe right here. Negative 0.4. Okay, so then let me take this off because this is going to change. Because this was thinking that this is when I was thinking that was -4, but it's not. It's -4/10. This is -4/10. So so that means that this is closer to 0. So that means that this is smaller. And that means this -1.3 is actually larger. So on the negative side of the number line, the closer you are to 0, then the bigger it is, right? So you write that down. So on the negative side of the number line, the closer we are to 0, then the larger the number. So yeah, so this is closer to 0 on the negative side of the number line. So then this is larger than that negative 1.33. Okay. So so then we go back to this negative 1.3 is smaller. Yeah, so let's fix these. So this gets closer to 0. So on the negative side of a number line, the closer we are to 0, then the larger the number. So this is closer to 0. So this is larger. And then this one is smaller. Okay. And so then we're going to say that, yeah, that this goes this way then. The negative 1.33 is less than the negative 0.4. Okay, so this negative 1.33 is less than this negative 0.4. Okay, so this one's larger. So I'm going to just highlight. I'm going to highlight this one. Is that okay then? So that's using long division. So the numerator, let me write this down also, that the numerator goes inside the house, which is the long division house. So this numerator, which was 4, goes inside. This 2 goes inside. The numerator goes inside when you do your long division. So that's one method you can do, the long division method. And then remember that they both happen to be negatives. So we're looking at the negative side of the number line. And then when we plot that, and just you want to be careful because remember, I made a mistake earlier, right? Because I didn't have this 0 there. So it's not, this is not -4, it's negative 0.4. And that was my first mistake that I made when I did that. That threw me off big time. And so be careful with that. And then the other mistake was just mislabeling. So I had to do the whiteout on that, but this is closer to 0 on the negative side. So this is large. And that negative 0.4 represents the negative 2/5. So this negative 2/5 is the larger one. Okay. All right. So that's one way you can show your work. The other way is to do cross products. So you have this -4/3, and you're comparing that to -2/5. And in the negative, if the negative is in the middle of the problem, you push the negative to the top, and then you do cross products like this. So here, -4 times 5, -4 times 5, that's a -20. And on this side, -2 times 3, -2 times 3 is -6. So the order does matter. If you're going to use cross products, you do have to kind of use this arrow usage. It does go this way. That is a requirement with the cross products. -4 times 5 is -20, and you are required to put the -20 on this side. So that is required to do that. And this kind of goes this way. So if I change my ink, it's blue, and that goes this way. -2 times 3 is -6. Okay, so now when you compare this on a number line, let's say you have 0 here. So -6 would show up first, and then as you move on out, -20 would be somewhere on this side. Okay, so again, on the negative side of the number line, the closer we are to 0, then the larger the number. So this is closer to 0, so this would be larger. This would be smaller. So this -6 is represented by what? See, -6 is represented by -2/5. So this -6 is represented by -2/5. So -2/5 is larger. And that's what we had agreed, right? We said that -2/5 was larger. So that says larger here. Okay. All right. So we should end up with the same result. We should end up with the same result, which is less than, except we're showing our work differently. This is using long division. This method is using cross products. And personally, I think this is easier. And then there is another one, which is the LCD and equivalent fractions. So on that method, let me come over here to part C, which is LCD. So if I look for the least common denominator, I have 3 and I have 5. So I'm going to use multiples. 3 times 1 is 3. 3 times 2 is 6. 3 times 3 is 9. 3 times 4 is 12. 3 times 5 is 15. And I think I'm going to stop there because I think I'm going to find a match. I'm going to find a least common denominator, which is a least common multiple. Those are synonyms. And so we're using multiples. Least common denominator is the same value as the least common multiple. So these are synonyms, and I'm using multiples. So 3, 6, 9, 12, 15. Then for 5, 5 times 1 is 5. 5 times 2 is 10. 5 times 3 is 15. And you see how we have a match? See how we have a match there? So the LCD, the LCM is going to be 15. Okay, so now I'm going to build up the fractions. So my fractions are this -4/3. And I'm going to build that up. So I'm going to multiply by a form of 1 based on what I need to get to the 15. So if I look at this 3, see, 1, 2, 3, 4, 5, 3 times 5 gives me 15. So I build this up by multiplying by a form of 1. 5 over 5 is 1. It's a form of 1. And I use the amount of multiples that are needed to get to the LCD of 15. So I use this and for 3 and I count 1, 2, 3, 4, 5. And that's where that comes from. Okay. And so -4 times 5 is -20. And 3 times 5 is 15. Okay. And I build up the other problems. Let me change my ink. And it's -2/5. And I multiply that by a form of 1. I'm building up my fraction. And y'all need to know how to do this whenever you're adding, subtracting fractions anyway. You need to know how to find a common denominator and then how to build it up. So this is good practice in that sense. So on the 5s, if I look at the 5, see how I need 3? Look, 1, 2, 3. So this is 5 times 3. That's a form of 1. 3 over 3. 3 over 3 is a form of 1. So 3 over 3 is a form of 1. And it's based on what's needed to get to the LCD of 15. So 5 times 3, see, 1, 2, 3. Okay, so -2 times 3 is -6. -2 times 3 is -6, and 5 times 3 is 15. So you see LCD and equivalent fractions, see? So these are equivalent, these are equivalent fractions in the sense that -20 over 15 is equivalent to -4/3. And -6 over 15 is equivalent to -2/5. It's the same amount. It's the same amount. So this represents the same amount quantity as this. That's why they say equivalent fractions. And you're finding a least common denominator. You see they're both LCD of 15. So when you have the least common denominators, then all you have to do is just compare the numerators. When we have the least common denominators, let me put that down here. When we have a least common denominator, then, and this is for both fractions, then we just compare the numerators. So when we have a least common denominator, then we just compare the numerators, okay? So we have a least common denominator 15, so we compare the numerators, which is -20 and -6. So that now is kind of reminder of this, right? It becomes it's all kind of united or comes together when we were comparing -20 and -6. So you just compare -20 and -6, and you know from this idea that -20 and -6 where it lands on the number line, then you know that the -6 is the larger one. This side is the larger side. This is the larger side. So again, that's the larger side. And when you compare, you know, equal, less than, or greater than, you're asking yourself, it's always with regards to the first fraction. Is the first fraction equal to or less than or greater than the second fraction? So when you're comparing, you always say it's in regards to the first. Is the first fraction equal to the second one? Is the first fraction less than the second fraction? Is the first fraction greater than the second fraction? So in this case, this first fraction, okay, is less than the second one, okay? So this is the smaller one, because you remember the -20 is out here, whereas the -6 is closer to 0. It's on the negative side of the number line, okay? All right, so when you take your test, you will have a problem exactly like this on the test. The numbers will be different, and you do have a choice. But when you show your work, you do need to show your work using either the long division or the cross products or the equivalents. Okay, so your teacher will want to see that work as for full credit. If you get the right answer, but you're not able to support your work, then you will not get the full credit for that. So like if it's worth, you know, 4 points, you know, maybe you get 2 points, you know, for the correct answer, or 1 point for the correct answer. But if you don't have the work, then that gets points taken off, because that, you know, it's like, you know, a point for this or a point for that, right? Do long division or point for the cross product, right? So that at least 2 points value for showing your work. Right? Okay. On problem number 2, compute the value of the following sum. So this is rule number 2. If you look at your rules here. Oh, and when you print the template, you can see that the first problem, see, this is on the test, you would put down whatever fractions the computer's going to assign you, any fractions, you would put that down, and you would show your work using those methods. And then this problem here is similar to your rules. It looks like you're doing rule 2. You're adding 2 sign numbers with different signs. So you're either adding 2 negative numbers, adding 2 sign numbers with different signs, or you subtraction. Well, you're not subtracting, because see, if you were subtracting, there would be a subtraction right there. So it can't be rule 3, because there's not a subtraction sign. You're not multiplying or dividing. You are adding. There is a plus sign there, but you're adding 2 sign numbers with different signs. So this is an example of rule number 2, which is adding 2 sign numbers with different signs. So that rule says what you're supposed to do is you're supposed to do two things. You're supposed to subtract, and then you're supposed to keep the sign of the number with the larger absolute value. Okay. So when I'm subtracting, I'm just like subtracting the absolute values. So let me start with the absolute values. The absolute value of negative 18.3 is 18.3. And the absolute value of 4.6 is 4.6, okay? And when I look at these two results, this is 18.3 has the larger absolute value. LAV stands for the one that has the larger absolute value, because 18.3, 18 and 3/10 is bigger than 4 and 6/10. So when I go back and I backtrack, see this sign right here? See how it's negative? That means that you're going to keep the sign of the number that has the larger absolute value. So LAV, the larger absolute value. This one has the LAV, the larger absolute value. So you backtrack and see how it's negative, not positive, it's negative. So that's like the winner, if you will. So that means your answer is going to be negative. Okay. And if I double check that aspect of number 2, see how it's going to be negative? Okay. And then see how they're getting 13.7? That's because they're subtracting. So now we're going to subtract. And I should say subtract the absolute values is what I should say. Subtract the absolute values. That's what I should say. Subtract the absolute values. So these were the absolute value results, and I should subtract these. So when I subtract those, 18.3 take away 4.6. So I can't do 3 take away 6, but I can make that a 13. And I can borrow from the 18 and reduce it, make it a 17. And 13 minus 6, well, I know 6 and 6 is 12. So 6 and 7, 7, 8, 9, 10, 11, 12, 13. And then 17 minus 4, that should give me 7 take away 4 is 3. So that gives me 13.7. You see, that's what they were saying here. Okay, so the answer is a negative. It's a negative 13.7. So we got the 13.7. So we subtracted the absolute values, but then you have to keep the sign of the number that has a larger absolute value. So it's either going to be positive or negative, and you can see we had to keep the negative because this one had the larger absolute value, 18.3. Okay. So when you show your work, please show your work similar to that. Now you can use the calculator to check your work, but I'm going to expect you to show your work. So on the calculator, you can go back and just type negative is down here. Negative is, this is a sign changer. This is subtraction. This is a sign changer. So negative 18.3 plus 4.6 is a negative 13.7. But you can definitely use your calculator. You bought a calculator. You can have a calculator. You can use that as a tool to check your work. But remember that any young child can just type, just a good typist. But I want the knowledge, right? I want the understanding of the rule that the book talks about. The book talks about, if you go back to your book, if you don't look at my YouTube videos, you go back to the book has, this should look familiar. These are the steps. And so I want to see you showing your work. I want to see you exercising this, that you're subtracting the absolute values. So here we're subtracting, and we're subtracting the absolute values, which were the 18.3 and the 4.6. And then you're keeping the sign of the number with the larger absolute value. 18.3 was larger, so you backtrack and you're going to keep the negative sign, not the positive sign, because you're not going to keep this plus because the 4.6 wasn't larger, the 18.3 was. So you keep the sign of the number, these two numbers that have the larger absolute value. So these are called absolute values. These bars are called absolute values. And those are absolute values. Absolute values are distance. You're taking these are distances. So if you think of a number line, here. So here you are at 0, and you have a measuring tape, and you're going out like 4.6. Let's say 4.6 is here. So you're taking a measuring tape, and that's distance. That's 4.6 units of length. It's distance from 0. That's what absolute value is. It's distance from 0 on a number line. So that's 4.6 units. But then the negative 18.3 is somewhere on the negative side over here. And you're taking your measuring tape over here, and you're measuring that, and that's negative 18.3 units here. But it's length. It's length. These are units of length. And nobody's ruler, nobody's ruler will ever have, you never see a ruler with negative on the ruler. So length is not negativity, right? No negative. So these are units of length measured from 0. So absolute value of a real number is always positive, okay? All right, okay, now here we're adding two fractions and you have different signs. So again, this is an example of rule number 2, which we just saw. We're adding two numbers with different signs. So we want to be able to identify what rule. Remember, here are your rules. Rule 1, are we adding two negative numbers? Are we adding two sign numbers with different signs? Are we subtracting? So if we were subtracting, you would have seen a subtraction there. And if you were multiplying or dividing, you would have seen a multiplication or division there. So it can't be 3 or 4. You do see adding, you see plus, but not two negative numbers. It's two signs with different sign numbers. So that's rule 2. But you need a common denominator. So you see, you want to be able to show your work using multiples. So on multiples, 22 times 1 is 22. 22 times 2 is 44. 22 times 3 is 66. 22 times 4 is 88. 22 times 5, and then that's where you can use this as a tool. 22, 5 is 110. 22 times 6 is 132. So I'm not sure how far to go out, but let's see if that's enough. So I'm gonna go to 33. So 33 times 1 is 33. 33 times 2 is 66. Oh, look, there it is. There's your match right there. There it is. 32 times 2 is 66. So there's your match, okay? A least common denominator, which is the least common multiple. So these are synonyms. Okay, so least common multiple, these are multiples, okay? So the denominator is 66. So now you're gonna build this up. So on the 7 over 22, you wanna multiply it by a form of 1 based on how many multiples you need. So you go to 22 and you count, see, 1, 2, 3, see, 1, 2, 3. So that would be times 3 here. Now, sometimes I see people do this. Sometimes I see people do this because they start with 22. So I see them do this, 44, 66, 88. And if you do that, because you're counting this, then you can do that, but then you have to be careful with your counts. Because if you're going to do that and like the first one counts 33, So then you say 66, so 33, 66. If you're going to write it up like that, that's okay. You have the first match. But then when you count how many 22s do you need, you have to remember to count from over here. 1, 2, 3. Okay, 1, 2, 3. Okay, so that's another way of doing it. I prefer this. I word it again. So it's 1, 2, 3. Okay. Okay, so that gives you 66. 22 times 3 is, and 7 times 3 is 21. Okay. Then plus, so I have a negative 5 over 33. So remember, if the negatives smack them in the middle, you just pull it up to the top, pull up to the top. And now you're going to multiply by how many 33s you need to get to the LCD of 66. So you can look here. So you see you need 1, 2. Okay. Or if you're writing it up like this, then you have to remember to count from back here. 1, 2. Okay. So negative 5 times 2 is a negative 10. 33 times 2 is 66. So you see now you have common denominators. Okay. And this is rule number 2. So remember what rule 2 says. You have to subtract the absolute values. And then you want to keep the sign of the number with the larger absolute value. So I'm going to take the absolute values. The absolute value of the 21 over 66 is just 21 over 66. The absolute value of negative 10 over 66 is 10 over 66. Okay, so these are the absolute values, just like we did over here, absolute values. And the one that's larger is this one. It just happens to be at the top. It's not always at the top, but it's also at the top. It's not always at the top. It just happens coincidence, but that's the LAV, which stands for the number with the larger absolute value, because see, the denominators are the same, 66. So 21 and 10, 21 is bigger than 10. So this is the large absolute. So when you backtrack, see how it's positive? So you backtrack, this is the larger LAV, and you can see it's positive. So you're gonna keep the positive sign. It's gonna be positive, okay? Let's put that there. It's gonna be positive, okay? So you don't have to put the plus sign on the paper, but it is gonna be positive, not negative, okay? And then, so you already kept the sign of the number with the large absolute value, it's positive, but now you have to subtract. So now we're gonna subtract these. So we're gonna do 21 over 66, and then we're gonna take away 10 over 66, okay? Or you can write it like this, 21 over 66, take away 10 over 66. So either way. So here I can use my calculator to help me. Just 21 take away 10 is how much? 21 take away 10 is 11. See, I have a little light here. 21 take away 10 is 11 over 66. And it was positive. We said to keep the positive. So it's 11 over 66. And I think that can be reduced again. I think that can be reduced by 11. I think we can reduce by 11. So you either write it out, reduce by 11, or when you show it that you're reducing, you show it like this. That. Okay, so 11 divided by 11 is 1, and 66 divided by 11 is 6. Can you see that? 11 divided by 11 is 1, and 66 divided by 11 is 6. So that gives you 1/6. 11 divided by 11 is 1, and 66 divided by 11 is 6. So that gives you 1/6. Okay. So another way of seeing that, 11 divided by 11 and 66 divided by 11, right? 11 divided by 11 and 66 divided by 11. So that would be another way of showing it. 11 goes into 11 one time. 11 goes into 66 6 times. Okay, so you get 1/6. okay? Yeah, 1/6, I wrote it wrong. 1/6, let me fix that. Not 11/6, but 1/6. Yeah, I was writing 11/6, but that's not the reduced version. This is an answer, but it's not reduced. This is an answer, but it's not reduced. This one is the reduced one. So this one is the reduced one. This one's reduced. This one's not. So I get, oh, and I'm going to check my answer on the paper. That's why I have my paper there. Yeah, see, number 3, 1/6. 1/6, okay? And you can see that they don't put the plus sign there, it's understood. So you don't have to put the plus sign, it's understood, okay? All right. So then, and you can see on your template, see, you're gonna have a problem where you're gonna have to add 2 fractions and find common denominator, okay? All right. So then now, let's go to this page. Consider the following absolute value expressions. The absolute value of -9, and this is the opposite of the absolute value of 11, or negative absolute value of 11. So they first want you to simplify the absolute value on the left side of the given. So they want you to find out what's the absolute value of -9. Okay, so that's just 9. Okay, so what happens is you have a number line, here's 0, here you are with a ruler, -9 is somewhere over here, and you're measuring from here to here. Okay, and that's units of length, just 9 units of length, 9 units of length, okay? And so this gives you absolute value of -9 is 9. And this here, see how the negative is outside? So this here, the negative absolute value 11, this gives you -11. Anytime you have a negative on the outside, then that's saying like take the opposite of. And so the absolute value of 11 is 11, but when they put the negative outside of it, that means they want you to take the opposite of the absolute value of 11. So the absolute value of 11 is 11, but now when you take the opposite of 11 is a negative. And so that's why this is a -11. So this is 9, and this result is -11. And now you're comparing these. So any positive number is always going to be bigger, right? So here's 0. Let's say 9's over here, and -11 sits over here. So any positive number, $9, I'd rather have $9 and be short needing, lacking 11. So 9 is greater than. 9 is greater than the -11. And remember, you always compare from left to right. It's always, this result is what? Is it less than or greater than, or is it equal to this result? So it's always looking at this first part is greater than. So if I look at the answer key for 4, they have the absolute value of -9 is 9, and then they say that it's greater than. Okay. So during the video, you can always pause it and stop it. You know, if you need to think about it or process it, you can stop the video for a few seconds, because of course I move on. but you can always pause it and think about that, ponder that, or rewind it and look at that. But then when you're ready, you go to the next problem. Next problem is number 5. Subtract negative 23 from 18. Okay, so in math, there's certain vocabulary words that mean to write in a reverse order, and this is vocabulary. This is vocabulary. Subtract from, that means to write the terms in a reverse order. So in other words, vocabulary that means to write the terms, or instead of maybe saying write, subtract the terms. Instead of write, subtract the terms in a reverse order. So you are subtracting, but you got to reverse the order. So what's first will go last. So you see how you have negative 23? So you have to, put another negative 23, because the subtraction is for the word subtract from. That's for the word subtract from. And then you're going to reverse the order of the terms. So these are your terms. This is a term, negative 23. This is a term, 18. So you're going to reverse them. So this term that's first will go last, and then this term 18 will go first. So that's the they call that a translation. That's the translation based on vocabulary. That's based on vocabulary. There's certain words that mean you have to write in a reverse order, and subtract from or subtracted from is one of them. So here's your subtraction, and you write these terms in a reverse order. Sometimes people make a mistake here because they'll forget that, but you need that, okay? And then now you're gonna fix that, because now in your rules, that is rule number 3. That is, you see, you're subtracting. This is now rule number 3, which is you subtracting 2, right? Sign numbers. So that's you subtracting 2 sign numbers, right? That's what they say here. Subtracting 2 sign numbers. So the rule, when you go to your book and you read your ebook, or you go to your YouTube lesson, or you look at your guided notebook, it will tell you the steps are keep, change to a plus sign. So keep, change this subtraction to a plus sign, and then take the opposite. Take the opposite. So keep the 18, change the subtraction to a plus sign, and then take the opposite. So the opposite of a negative 23 is a positive 23. And then now you look at that with fresh eyes. You look at this with fresh eyes, and you don't need a sign rule. So now no sign rule needed. You don't need a sign rule to add 18 and 23. You just add those up, 18 and 23, 8, 9, 10, 11, carry your 1, 2, 3, 4. And then you just double check on your calculator. 18 plus 23 is 41, okay? Okay, so now let me check that work. If I go to my answer key, go to number 5, there it is, 41. Okay. Okay, let's see. Translate the following phrase for number 6 into an algebraic expression. This is do not simplify. Use the variable names x or y to describe the unknowns, the unknown variables. So product means to multiply. That's vocabulary. 2 numbers minus 5. Okay, so the two numbers are the unknowns, and we're going to use x, y because it's product. So those are the two numbers, the variables, x, y. Product means multiply. Minus means you subtract. Minus means that you do subtract, but not in a reverse order. It's not one of those special words. You subtract in a straight forward manner. It's not one of those special vocabulary words. So minus 5. So that should be the answer. XY minus 5. And you cannot simplify that any further. So let me check my answer key on that. Number 6. Okay, and they put parentheses around the XY. I didn't, but I think the computer will still accept it. I don't think it's required to put the parentheses. I think you're okay without that. Okay, determine for number 7 whether or not the given number is a solution to the given equation by substituting and then evaluating. Okay, so they want you to substitute and then evaluate. Okay, so here you want to find out if is -3 a solution. So they want you to substitute into this equation. So the equation is -4 plus x. And they're saying, does that equal -3? That's what you're trying to find out. And they're telling you to substitute everywhere you have an x, you want to replace an x with a -3. So right here, -4 plus -3. So everywhere you have an x, you want to replace that. And this is rule number 1. This is rule number 1. Rule number 1 is you adding 2 negative numbers. That's you adding 2 negative numbers. So the rule says to add and to keep the negative. The rule says to add and to keep the negative sign. So -4 plus -3, -4, -5, -6, and -7, and you keep the negative sign. Okay, so on the calculator, you're doing -4 right here, -4 plus -3, okay, which is -7. So -4 plus -3 is a -7. So you use this sign changer, -4 plus -3, and then enter. This is -7. Okay. And so now what? Let's see. Now, okay, let's go back over here. So the question was, does that equal -3? Does that equal -3? No. So that's false. No, that's false. The left side is supposed to equal the right side. If it were a solution, it would be true. If it were a solution, it'd be true, but it's not a solution, it's false. So I would go with -3 is not the solution. And I'm going to just, before I circle that, I'm going to double check number 7. 7, yep, -3 is not a solution. Yeah, so it's not a solution. And it's not because it equals -7 instead of. -3 is not a solution. Why? Justify it. Why? Because the result equals -7 instead of a -3. It's supposed to equal -3 according to this right here. According to this, it was supposed to equal -3, but it didn't. It equaled a -7. So it's not a solution. But you see, you follow directions. You substitute it, and then you evaluate it. Okay. All right. Okay, now let's go to number 8. And then again, on the template, if you print the template, you can see how we did a problem similar to 4. See when you're taking absolute values, see subtracted from problem, you do translation, simplify. and then see even that. So substitute C, we just did that one substitute value. So very similar. And now it looks like we're going to do properties of real numbers now. So identify the property of real numbers illustrated in the following equation. Okay, 5y plus its opposite, negative 5y, that's its opposite. So this is a number plus its opposite. So you know that a number plus its opposite equals 0. A number plus its opposite equals 0. It's a property. Now, in your workbook, in your guided notebook workbook, your workbook has like 3 portions. It's like what's a combo workbook, your guided notebook. The first part has the math 0105 correct part. Then you have your study skills, which are like 11 articles of reading. And then you would read the article and then tackle your little homework related to the math study skill. And then the second part combo has the 410 part. So in the math 105, I think this is right before the study skills. I think right before the study skills. See these Roman numeral pages? XXIII, so that's 10, 20, 23, and then 10, 20. So you see how you have, principles and properties of addition and multiplication. And you can use this when you take the quiz. You can have this study guide out. You can use the study guide to jog your memory. And you can also have these sheets out. So see, this is a commutative property for addition and multiplication. Commutative means that the order changes. The order of the terms change. Okay, you can see the order changes. A, B, and then B, A. A times B, and then B. So the order changes. Associativity means the grouping changes. So notice how the order stays the same. Look, A, B, C, A, B, C, see? A, B, C, A, B, C. The order stays the same, but what changes is the grouping, the associativity, the grouping. So the parentheses, the grouping symbols change. So first it's wrapped in the front, then it's wrapped in the back. So it wraps the first 2, then it wraps the last 2. See, here it wraps the last 2 of the product, the factors, then it wraps the first 2. So the order change, the parentheses changes. Identity means like a mirror reflection, like you get the same thing back. So A plus 0 equals basically A, and A times 1 equals A. So identity is like either you get the same result back. You see itself back, like a mirror reflection, but you have one for adding and multiplying. And then this is what we have. We have inverse. See, a number plus its opposite zeroes out. That's what we had. We had an inverse of addition. That was this right here. So I would say that that looks like it's addition inverse. Yeah, so inverse, addition, additive, inverse. I think that's going to be H. So if I look at my answer key on number 8, additive inverse property, additive inverse property. Yep, additive inverse property. So it is H. Yeah. And so you can use this because you will have a problem like that on your test. You just don't know which one the computer is going to randomly give you, but their properties are here. Now, this is also inverse, a number times its reciprocal. So a number plus its opposite zeroes out, and a number times its reciprocal. A, if you flip A over 1 is 1 over A. A number times its reciprocal just equals 1, because these A's will divide into each other and just give you 1. Then you have the zero factor law. Any number times 0 equals 0. And then you have distributive property. So distributive property says, I'm going to put the arrows here, A times B, and then plus A times C. So distributive property, A times B plus A times C. So those are your properties. So you can use that to help you when you get that problem. Okay, down here, you want to, again, show your, you can use a calculator as a tool, but you need to first show your work. So show 5 times negative 11, right? So you have negative 11 times 5, 5 times 1 is 5, 5 times 1 is 5, and then negative times a positive is a negative. So that's negative 55. Then you have negative 55 times a negative 2. 5 times 2 is 10, carry your 1. 5 times 2 is 10, plus 1 is 11. Negative times a negative is a positive, okay? And then you have 110 times negative 6. I have this one. 0 times 6 is 0, 6 times 1 is 6, 6 times 1 is 6, and then it's a negative. 110 times negative 6 is negative 660. So it looks like that's a negative 660. So the rule says 2 at a time, 2 at a time. Same signs produce positive results. Different signs produce negative results. So see, different signs, negative results. Different, oh, this is same signs, positive results. Different signs, negative results. So this is taking them 2 at a time, 2 at a time. So 2 at a time, okay? So first it was different signs, negative results. Here, same signs, negative, negative, positive results. In this one, different signs, negative results. Okay. All right. And then of course on a calculator, if you double check that, you're doing 5 times a negative 11 times a negative 2 times a negative 6. So negative 660. Yep. Okay. And then if I double check that on the answer key, number 9. Yep. Negative 660. Okay. Okay. Number 10. Looks like we're multiplying these two fractions together. So multiplying across. The way you multiply fractions, I just multiply straight across and then I just try to reduce. That's one way to do that. So those are big numbers. Let's see, 5 times 45, and it's actually negative 5. Negative 5 times 45, but that's gonna be a negative 225. And then 18 times 7 is 126. But then you want to reduce that. So you want to try and reduce that by a number. Let's see. We do have some divisibility rules. Let me just take a look at that sheet. I don't know if you remember divisibility rules. Yeah. You can also use this sheet here and just help you for quiz 1, but can that be reduced? So if I reduce it by 2, it would only be because the numbers, both numbers ended in a 0, 2, 4, 6, or 8. So that messes this up. The 6 is good, but the 5 isn't there. So this can't be reduced by 2. And if I want to reduce it by 3, I'd have to sum the digits. And then when I add them up, it has to be reduced by 3. But I think on this first one, if I add 2 and 2 and 5, 2 and 2 and 5, 5, 6, 7, 8, 9. Okay, well, 3 goes into 9. That does work. 3 goes into 9 3 times. So that does work. But I don't know about the other one, 1, 2, and 6. 1, 2, and 6. If I add those up, 6, 7, 8, yep, 6, 7, 8, 9. Yeah, And I know 3 goes into 9. Yeah, so I think 3 would be a common divisor for that. I think 3 would work. So the divisibility rule for 3 says, if and only if you sum all your digits of your whole number being tested, and that's divisible by 3. Okay. So what we did was we summed the digits. So you see here for 225, I summed 225, and then over here for 126, I summed them. I got 9, and those then divisible by 3 have to be divisible by 3. So I divided by 3. 3 goes into 9 3 times. Yeah. So now I believe that works. So now I'm going to use the calculator and do, and I know it's negative. So 225 divided by 3 is 75. And 126 divided by 3 is 42. And I think that can be reduced again by another 3. Because if I add 7 and 5, 7 plus 5 is 12. And 12 is divisible by 3, get a remainder of 0. And if I add 42, see, 4 and 2, 7 and 5, 4 and 2. If I add 4 and 2, that gives me 6. And 6 divided by 3 is 2. Yep. Yeah, so this can be reduced again by 3. Okay. Because of that same divisibility rule by 3. So 75 divided by 3 is 25. And of course, it's going to be negative. Is that negative there? And 42 divided by 3 is 14. But then I don't think that can be reduced again. Because if you add 2 and 5, you get 6. So if I add 2 and 5, I get 6. And I know 6 is divisible by 3. But what messes that up is the 4 and 1. If I add 1 and 4, that gives me 5. And you don't get a remainder of 0. 3 goes into 5 one time, and then you get a remainder of 2. You want to have a remainder, see, of 0. So 3 doesn't go into 5 evenly, not evenly. Get a remainder of 2 instead of 0. So it does stop there. But it looks like that's going to give you a negative 25 over 14 for number 10. 10, yep, see, negative 25 over 14. Yeah. So negative 25. And that's improper. This is improper. And it doesn't say that it has to be a mixed number. If you make that into a mixed number, if you do long division, because you are going to have to do that for test 2 anyway. You do have to know how to do that for test 2. The top number goes inside the house, and it is going to be negative. 14 goes into that only one time, because otherwise, if you did 14 times 2 is 28. That'd be too big. But 14 times 1 is 14. 5 take away 4 is 1. 2 take away 1 is 1. So it looks like you have a remainder of 11. And it goes clockwise. You record it clockwise. So it's negative 1, and 11 over 14. And so you can say it's negative 25 over 14, or you can say it's negative 1 over 14. And if you wanted to check that, negative 25 divided by 14 is this decimal. And here, the way you would do this is you would have negative 1 plus this, 11 divided by 14. Oh, wait, it would be negative 1 plus, this whole thing is negative. So it would be negative 1 plus negative 11 over 14. So negative 1 plus a negative 11 over 14, because this whole thing is negative. And we should get the same thing. See that? So if you're unsure if you did that, if you made it, this is a mixed number. If you're unsure if you did that correctly, you could kind of double check. That is a mixed number there. And it gets recorded clockwise. You record clockwise. Okay, but it just said simplify your answer. It didn't say that it had to be made into a mixed number. So we reduced it. We reduced it because we had that originally. We're fine with that. Okay. And I think I double checked. I double checked 10. Yeah, negative 25 over 14. Okay, and then if I look at your paper here, just your template, see, find the product, which we did, and then a multiplication of fractions. So you see, and now what's coming up is a division of fractions. Okay, so that would be number 11. Perform the indicated operation and simplify your answer, and it's division. Okay, so what happens with division, notice how we don't find common denominators. You only find common denominators for adding, subtracting. So I'm going to put a note over here. I'm going to put a note when you're multiplying. I'm going to say, do not find a LCD, which is an LCM. Not for multiplying fractions, only for adding and subtracting. And also, I'm going to put that here. Do not find a LCD, LCM. Okay. So what happens here is you want to do keep and change. Here, you're changing it to a times. And then you're going to flip. Or they say, take the reciprocal. So it's a little bit different from another rule. We had another rule earlier that said keep change. Let me go back to that. Where was that at? We had, okay, this is a different rule, but similar, but still different. We had this rule here where we said rule 3, subtracting two sign numbers, keep change, but we change it to a plus sign. And then we take the opposite. So kept the 18, changed the subtraction to a plus, then we took the opposite of the negative 23, which is 23, okay? But this is a little bit different here. We change this division to times, and then we flip. We take the reciprocal, okay? So negative 36 over 7 times 5 over 63. And then the way you handle fractions, now it becomes like number 10. So remember what happened 10, or number 9, excuse me, number 9. No, number 10. The way we multiply fractions is we multiply straight across and then we reduce. So let me write that down over here. So we multiply straight across, and that's on top and on the bottom. So on top and the bottom. So in the numerator and the denominator. So top is numerator, bottom is denominator, and then we reduce, okay? Then we reduce. So that's what happens after you rewrite it and you keep, change, times, and flip, take the reciprocal, then you multiply straight across, and then you reduce, you know, if possible. Not all the time can it be reduced, but if it can, you want to try and reduce that. So that's a big number, let's see, and it's negative. So 36, negative 36 times 5 is a negative 180. And then 7 times 63, those are big numbers, is 441. Yeah, so then you want to try and reduce. And remember what I was doing was I was using the divisibility rules. So I know I can't reduce by 2 because it has to end in a 0, 2, 4, 6, or 8. And the 0 is there, but not on the bottom. It doesn't have a 1. So I can't reduce that by 2. And if I try to reduce it by 3, I'd have to add up the digits. So if I add up 1 and 8 and 0, that's 9. So that looks good. 9 is divisible by 3 with a remainder of 0. And now let me check this. 4 and 4 and 1. Yeah, 4 and 4 is 8 and 1 is 9. Yeah, 9 is divisible by 3. So yeah, this can be reducible by 3. And maybe, you know, we might be able to reduce it by 3 again, but let's just start with that. So it's going to be negative. So 180 divided by 3 is 60. And 441 divided by 3 is 147. Okay. Now let me see if I can be reduced again by 3, because I know 6 and 0 is 6. So I know 6 divides by 3. So I know that will work. But let me check the 1, 4, and 7. 7, 8, 9, 10. Yeah, that's 12. Yeah. 12 divided by 3 is 4. Yeah, so it looks like that can be reduced again by 3 again. Okay, so it'll be negative. Okay, so 60 divided by 3 is 20. And 147 divided by 3 is 49. But then I don't think that can be reduced again by 3, because if you add up 2 and 0, you just get 2. 2 and 0 is 2, and then you can't 2 divided by 3. 3 won't go into it. This is just too small. It stops there, so you cannot. I mean, you're going to get a decimal. If you keep going, you can see. I think that's 6 times 3 is 18. But you want a remainder of 0, and you can see you get a remainder of 2, and you can see that's 0.6. You were going with that. That's not going to take us anywhere to where you get a remainder of 0. I think it's going to be repeating, because if you add another 0 and pull it down, you get, again, 6 times 3 is 18. Yeah, so it's like a repeating, 0.6 repeating. So yeah, but the point is that you cannot be reduced by 3 anymore. Also, I think you have a list of prime numbers in your workbook also. You have a multiplication chart in your workbook. You have this grandioso multiplication chart. That's Roman numeral 7. And then on the back, you have Roman numeral 8 here. And I think this is in the correct part of your workbook, but you have prime numbers. So a lot of times I'll try to reduce by 2, I try to reduce by 3, usually I try to reduce like this by these first 2 rows. And if the number cannot be reduced by these first 2 rows, then it probably can't be reduced at all, So I usually try that, but you can see the 2 and the 3 fit just well with this divisibility chart here. See, we've been getting a lot of progress, because the other thing you can test are, for 5 is easy if it ends in 0 and 5. 10 is easy if it ends in 0. 4, you would have to take the last 2 digits. If you look at the last 2 digits, then that can be, and 4 goes, it can be divided by 4. The last 2 digits can be divided by 4. You get a remainder of 0. That will work. Okay. So I don't think that can be reduced again anymore. That's lowest term. So if I double check that negative 20, see where my answer key is at. This is number 11. Yep, see, negative 20 over 49. Okay. Okay, number 12, simplify the algebraic expression by combining like terms, similar terms. Okay, so in order to combine like terms, you need the same base and you need the same exponent. And that would be to have permission to do what? To actually combine the coefficients. And the coefficients are the numbers in front of the letters of the variables. So in order for you to be combining those coefficients, you have to have the same base and the same exponent. So I think if I use my markers here, you know, you usually start with the highest exponent, which is the exponent of 2 higher. So you could start, those have the same letter X and the same exponent 2. So same base X and the same exponent of 2. So then you can combine the coefficients. And if you wanted to, you could stack them like that. You wanted to. You have the same base and the same exponent, so you can combine these coefficients. And this looks like rule number 1. You remember rule number 1? Rule number 1 is you adding 2 negative numbers. So for rule number 1, you just add and you just keep the negative sign. You remember that? So 8, 9, 10, 11, 12, 13, 14. So it looks like a negative 14. And then it's x squared. So you want to do a little check on the calculator. You cannot put the x squared in, but you can put the negative 8. There's negative 8 plus negative 6. Negative 8 plus negative 6, which is negative 14. And don't forget to keep the base x squared. So that's the first one term. And then going down after x squared, you come down, descending order would be the 5x's, in this case, a negative 5x, and the exponent is 1. And then constants last. Constant last is a plus 7. That's a constant. Constants go last. So it's x squared descends down to x to the first power, descends down to constant. That's called algebraic order. X squared descends down to x to the first, descends down to constant. And then negative exponents, if you're curious what follows, constant are the negative exponents, x to the negative 1, x to the negative 2, x to the negative 3. Those look like that. 1 over x squared. That's x to the negative 1, x to the negative 2. So that's what follows after constants, okay? So we have negative 4x squared and then negative 5x and then plus 7. So I'm going to check that for 12. Negative 4x squared, negative 5x plus 7. Okay. Okay, number 13, simplify the algebraic expression by performing the indicated operations and combining the similar or like terms. Okay, so first you have to do distributive property first. Before you can do something like we did here, you first have to do your distributive property. Okay, so 5 times 2x is 10x. So if you want to do a little bit of math, you can do something like that. That helps you. And then 5 times 3y is a positive 15y. So you wanted to do some work. I guess you could do this too. 3y times 5 like that. Stack them. It's 15y. So that's one way to show that. Okay, it's an idea. And then you want to be careful here because see, this is negative. That's a negative 1. That's going to change all your signs. So negative 1 times x, that's confusing there. But negative 1 times x is negative 1 times x that equals negative x. Okay, so that's negative, right, negative x. And then negative 1 times 4y, negative 1 times 4y is a negative 4y. Okay, so the rule here says different signs produce negative results. I think you heard me say that earlier. Let me see. I think you heard me say that earlier on this problem here. See, different signs give you negative results. See, same signs give you positive results. Different signs give you negative results. So this when you're multiplying, it's 2 at a time, multiplying 2 at a time. So that's kind of what's happening here. You're multiplying 2 at a time, and it's different signs. Multiplying 2 at a time, it's different signs. So that uses that rule that different signs produce negative results. And that's only when you're multiplying 2 at a time. So you're multiplying 2 at a time. We're not talking about adding or subtracting, we're talking about multiplying. Okay, and these are same signs. Same signs produce positive results, right? So same signs produce positive results. Okay. All right, now we can kind of do something like this where we're looking to have the same base and the same exponent to combine the coefficients. And I think what's like our the x's, right? X to the first power, x to the first power, those are the same base of x and the same exponent 1. So you can group those and you can stack them. There's like an imaginary 1 there. So here you don't really have to put a plus sign here because it's 10x take away 1x. So really you don't need an extra plus there. It's 10x take away 1x, which is just 9x. And then the other like terms, if I use my other marker here, 15 take away 4y. So you have a 15y and you take away 4. So you don't really need a plus sign here. So you got 15 and you're taking away 4. So these are not sign rules, because if you have 10, you can take away 1. If you have 15, you can take away 4. You're not shy, you're not short. This was a sign rule. That's why I had the plus sign here, because this is a sign rule. This is a negative 8 plus a negative 6. That was a sign rule. And 2 negatives, you add them up to keep the negative. These are not really sign rules. It's just 10 take away 1 is 9, 15 take away 4 is 11. And then just don't forget your variables. Sometimes people just say 9 or 11, don't forget the variable. So you should alphabetize them. The 9x should go first, and then it is a positive. Don't leave a gap. Don't leave a gap. But it's alphabetical order. The x's come before y's in the letters of the A, B, C, D, right? X, Y, Z. Okay. So on 13, you have 9x plus 11y. Okay, evaluate the following algebra expression at x equals 4, y equals -3, and then simplify. So you basically want to substitute. So you're going to substitute -5 times x is 4 squared minus 5, y is -3 squared minus 9. So you're going to substitute, okay? And then after you substitute, you're kind of like evaluate, right? You're going to do like your order of operations. So I would say evaluate using PEMDAS. Please excuse my dear Aunt Sally, which is order of operations. So I would start, you don't really have anything inside, like you don't have operations inside parentheses. Like I have parentheses here, but I don't see anything like this, like you adding. This is an operation inside parentheses. That would be like 7, right? That would turn to 7. I don't see like any operations inside parentheses. So you really get to skip, P, doing operations inside parentheses. These are operations inside grouping symbols. So you don't have that going on here. You get to skip the P. But you do have E, you do have check mark there. You do have E, you don't have absolute values and you don't have perfect square roots, but you do have exponents. And that's 4 times 4, which is 16. And that's -3 times -3, which is 9. So you do have, you put a check mark on E, you do have E. 4 times 4 is 16, -3 times -3 is 9. So now you need to rewrite. So now you have -5, and now this is times 16 minus 5 times this is 9 minus 9. You do have to do a rewrite there. But then when you go back to your order of operations, MD, not for medical doctor, MD, but multiplying or dividing left to right. So MD is, it should be M or D, multiply or divide. And it depends, it's from left to right. So you have to be flexible. You might multiply sometimes first, you might divide sometimes first, it depends on your problems. You have to be flexible. But MD doesn't mean that you always multiply. It doesn't mean that. It's multiply or divide. It's whichever comes first. Whichever comes first. Multiply or divide from left to right. So when I look at this, like I'm reading a book from left to right, I see this first. So I am gonna multiply that. Okay, -5 times 16. So how much is that? It's -80. -5 times -80. It's -80. And then here, I'm going to say that this is just 5 times 9, because this is also multiplying. But see, there's a subtraction here. So I'm going to just bring the subtraction down, and I'm going to just figure 5 times 9, which is 45. And then bring down the -9. Yeah. So I'm multiplying -5 times 16, which is -80, and I'm only multiplying 5 times 9. 5 times 9, because this is subtraction. Because you do have AS. So we were handling the multiplying, dividing, multiplying. We have multiplying. Now we have the AS, which is a lot of S, a lot of subtraction. So that's why I treat that separately, because we have subtraction. And so when I subtract, I have -80 take away 45. So remember what we said about the rule for subtraction? It's keep, change, take the opposite. I don't know if you remember that from over here. When this rule number 3 for subtracting sign numbers, keep, change the subtraction to a plus, take the opposite. So keep, change the subtraction to a plus, take the opposite of the second number, okay? So keep the -80, change the subtraction to a plus, and then take the opposite. And the opposite of 45 is a -45. So we keep, change the subtraction into a positive, and then we take the opposite of 45, which is a -45. And then look, that becomes rule number 1. See, that becomes a rule number 1, which is, remember what rule number 1 is? Rule number 1 is adding 2 negative numbers. So you just add and you keep the little negative. So if I add and I keep the negative, 0 and 5, 8, 9, 10, 11, 12. Looks like it's a -125. And of course, you can double check on your calculator. -80, plus negative 45, it's negative 125. So that takes care of this. Keep, change, take the opposite. So that gives me negative 125. So now I have negative 125, and then see, minus 9. Okay, so again, that's a rule number 3. So let me go back over here. Let me see. This was a rule 3. Keep, change, take the opposite. So this is again a rule number 3. And remember, rule number 3 is subtracting. See, rule number 3 is subtracting 2 sign numbers. So you keep, change, take the opposite. That's what your book taught you. That's what we did in the YouTube. That's what your guided practice says. If you look at your notes, keep, change, take the opposite. So keep, change to a plus, and then take the opposite. Opposite of 9 is a negative 9. Okay, and then look, this becomes rule number 1. Rule number 1, which is adding 2 negative numbers. When you're adding 2 negative numbers, you add and you keep the negative. So if I add those up, nine, 10, 11, 12, 13, 14, carry your 1. 2 and 1 is 3, 1. It looks like that's going to be a negative 134. You can double check on your calculator. Negative 125 plus negative 9 is a negative 134. Okay, and if I double check that on the paper, it's negative 14. Let's see what my answer key says for negative 14. Negative 134. Negative 134. Yep, that's what we got. Okay, and then on 15, also kind of doing the same thing. You're kind of substituting and then evaluating. Kind of the same thing as the substituting and then evaluating. And then evaluating, and when you're evaluating, you're using the PEMDAS. Please excuse my dear Aunt Sally. So kind of the same idea, but except you have like a little fraction form. So this is negative 9 times x, which is 4, minus 2 times y, which is negative 2, and then negative 2 times z, which is 4. Okay, and then what happens is you kind of have like, when you evaluate, you evaluate like the numerator separately and then the denominator separately. And so negative 9 times 4 is a negative 36. Double check that. Negative 9 times 4, the negative 36. And then again, remember, this is a minus sign. And then I'm multiplying just these two times negative 2, which is 2 times negative 2, which is a negative 4. So double negative. Okay, so negative 9 times 4, 2 times negative 2. Okay, and then this is rule number 3. You're subtracting sign numbers. So keep, change, take the opposite, right? So keep, change to plus, take the opposite, right? So negative 36 plus, and the opposite of a negative 4 is a 4. So you have negative 36 plus 4. Okay, and that was because that was a rule number 3 right there. That was a rule 3 subtraction of sign numbers. Now you have rule number 2. Remember rule number 2, when you're adding 2 numbers with different signs. You remember that? Rule number 2, you're adding 2 numbers with different signs. If I go back to a problem where we're doing rule number 2. Remember rule number 2, adding two numbers with different signs. You want to subtract the absolute values. You want to keep the sign of the number with the larger absolute value. Remember that? So I'm going to show taking the absolute values, see which one's bigger, has the LAV, go backtrack to the one that has the largest absolute value, and then that will tell me my sign. And then I'm going to actually subtract the absolute values. Remember that? So that's what I'm going to do here. The absolute value of negative 36 is 36, and the absolute value of 4 is 4. And it just looks like the top one is always the largest, but that's not the case. That's not the case. It's just that this is the third time you see me use this, and it happens to be on the top, but that's not always going to happen. Sometimes it's down here. But here, 36 is bigger than 4. That is the LAV, which is the larger absolute value. And you backtrack. And when you backtrack, you get a negative there. Okay. So that means that you're going to keep the negative. Okay, so I'm going to come over here and keep the negative. Okay. And then I'm going to subtract. So when I subtract, I'm subtracting these two. 36 minus 4, 6 take away 4 is 2. That's 32. So that gives me a negative 32. And then when I check on my calculator, negative 36 plus 4, it's negative 32. Okay. And then on the bottom, negative 2 times 4, that's a negative 8. Okay. And then this can be simplified because 8 goes into 32 exactly. If I do 32 divided by 8, it goes into it 4 times. Exactly. And then the signs are the same. So remember how we said same signs, multiplying them 2 at a time? Well, that rule applies. Remember this here? Multiplying 2 at a time, different signs, negative results, same signs, positive result. Well, that rule is also for 2 at a time for dividing. So when you're dividing 2 at a time, dividing 2 at a time, the rule says same signs produce positive results. And if you had different signs, different signs give you negative results. Okay. So we have the same signs give you positive. So this is going to be a positive 4. So let me check that. Number 15. Yep, 15 is a 4. See that? Okay. So what happens when you have a fraction, you kind of have like 3 parts. The first part is a numerator. Find out what the numerator is. So you substitute and you evaluate using PEMDAS, which is order of operations. And then on the bottom, you have to simplify the bottom. The bottom is much simpler than the top. But then you also have to simplify or reduce or simplify, and this ends up being a whole number. It'd be 4. Okay. But we still kind of had the idea of substituting and then evaluating using PEMDAS, which is what we did on 14. It's just this was a fraction form, numerator and a denominator. Okay. So going back to our template, our template, remember this was division. So see, that was this division here. And then we had simplifying the expression. So you see, so the template does go hand in hand with what we're working with. And then on our template, you can see here, simplifying and y equals x equals, see, you may use PEMDAS, see x equals y equals. So that's kind of related to what we were doing here, it seems, right? Lines should be kind of matching. The test is very similar, just I go back and change the numbers on the computer, gives you different numbers. And then 16, what's coming up next is finding the perimeter. Include your formula, your substitutions. That's a point for the formula, a point for the substitution, a point for units on your paper, okay? And let's look at 16. So it's 16. Get this out of the way. Where is my 16? Let's see. Papers we're using. Other papers that we're using. So now another one, we're going to be the formula sheet. This looks like it's Roman numeral 20 in your workbook. And I don't remember when I pulled it out. I honestly don't remember. Yeah, it looks like it's in the after the study skills part. So and here we go. I'm looking for 16. Okay, find the perimeter of the rectangle. Okay, so you want to look for your teacher's going to want the formula. So if you look at this formula sheet, geometry, perimeter and area. So you want to be careful and not get confused because the top part are perimeters. The bottom part is area. So you want to be careful when you choose the formula. The P is for perimeter, the distance around an object. That's what perimeter stands for. Perimeter stands for the distance around an object, whereas A stands for area. So area is you're filling in space. You're filling in the space with carpet, air spoils, covering that space up, area, space. So area is like kind of like space filled, right? So perimeter is distance, and area, I guess you can kind of think of it as maybe a space that's filled, maybe. I hope. Okay. So so you want the rectangle. So you want to look at your figures. This is a rectangle, this is a square, this is a triangle, this is a parallelogram, this is a trapezoid and a circle. You want the rectangle and you want the perimeter. So you don't want the A, that's area, you want the perimeter. P equals 2L plus 2W. So your teacher's going to want that. That will count for a point. And then your teacher wants the substitutions, 2 times the length plus 2 times the width. So L stands for length. W stands for width. So the length is 20 centimeters and the width is 7 centimeters. Okay. So 2 times 20 is 40 centimeters. 2 times 7 is 14 centimeters. And then you're adding that. 4 and 0, 4 and 1. Looks like 54 centimeters. So that's units, not units squared. The area is units squared, that's centimeters. So if I check my answer, number 16, 54 centimeters. Okay, find the area of the trapezoid. Okay, so trapezoid is this figure here, and here's the formula. Area equals 1/2 times height, parentheses, base plus C, bottom. You have 2 bases, a bottom and a top, B and C. So area is equal to 1/2 H, B plus C. Okay, I'm going to substitute. H is the height. So here's your height, which is 8 meters. So I put 8/1. It matches. And then I'm going to put a bracket. You can do parentheses or bracket. I'm going to do a bracket. Well, I guess I can do parentheses. These are grouping symbols. Consistency. So B, according to this is B down here. And this is C on top. So they be consistent. B is 24 meters. And the top is C, 13 meters. Okay. Right. So you, in the order of operations, PEMDAS, please excuse my dear Aunt Sally. You do, I'm gonna put a check mark on P. You do have, this is an operation inside grouping symbols. So you do have a true P. So I'm going to add 24 and 13. 4 and 3 is 7. 2 and 1 is 3. So 24 plus 13 is 37. So you would do that first, operations inside grouping symbols first. So according to that, you would do that first. So then you'd have 1/2 times 8/1 meters. And now this is, times, now that's just 37 meters. And then we don't have any exponents. We don't have any absolute values. We don't have any perfect square roots. But then we go to MD, which is multiply and divide, but from left to right. So this is like a big multiplication. See, times 1/2 times 8/1M times 37M. This is like a big times problem. So we do have multiplication. And if I just start 2 at a time, if I start here with this, multiply fractions across, 1 times 8 is 8, and 2 times 1 is 2. And then the cool thing is that simplifies, because 8 divided by 2, that goes into that, 2 goes into 8 4 times. So that's actually 4 meters times 37 meters. And now 37 meters times 4 meters. 7 times 4 is 28. 4 times 3 is 12, plus 2 is 14. And meters times meters, when multiplying like bases, you keep the base and you add the exponents. So you keep the base of M and you add the exponents. And that's how come that gives you M squared. So when multiplying like bases, we keep the base and we add the exponents, because we're going to have a test 4, which is on chapter 12, polynomials, and you're going to need to learn that rule, that M times M, that those have little ones on them, and you keep the base and you add the exponent. And that's why units is areas units squared, meters squared. That's the reason why that works out. So 4 times 37, you saw, was 148, and then it is meters squared. And that's why on your paper, your teacher wants the formula, the substitutions, and then the units, okay? And then do your math, but then double check on your calculator. And we should, number 17, we should get 148, 148 M squared. Okay, classify the following real number, and we're classifying 15. Okay, so there is in your workbook, there was a page related to that. At least I can find it. Okay, it was on this Roman numeral XXII, so that's 10, 20, 10, that's 10, 10, 1, 1. So 10 and 10 is 20, 21, 22. So that's Roman numeral 22. It's called notation and terminology. So notation and terminology. And if you go down to the bottom, see, it says types of types of numbers. See, so we have natural numbers, which are counting numbers, how you can count on your fingers on your hand. See, those are natural. See the symbol? We have whole numbers, W. So whole numbers are the natural numbers, except you also include 0. So you can see for 15, see, these are called ellipses, dot, dot, dot. Those are ellipses. It goes on forever. So see, 15 would fall under a natural number. So 15 is considered a natural number. Okay. And then 15 is also considered a whole number because the whole numbers just have the extra number of 0. But you could see 15 would fall there. So 15 is also a whole number. Okay, then after whole numbers, you have integers. So that's a Z. So see, after 4, dot, dot, dot. So yeah, eventually you would get to 15. So wow, 15 is also an integer. Okay, now a number is either going to be a real number. These are all real numbers here. Well, actually, let me take that back. Up to here is real numbers here. A number is either a real number. Let me say that again. A real number is either rational or irrational, but it can't be both. A real number is either rational or irrational, but it can never be both. So you just have to look at the descriptions here. Rational number, a number that can be written in the form A over B, where A and B are integers, B is not equal to 0. Irrational number, a number that can be written as an infinite, meaning goes on and on and on and on forever. Non-repeating decimal. Okay, so you would have a decimal, but it wouldn't repeat. You just like a long division problem that would be ongoing. So like a rational number would be like pi 22 divided by 7, which is 3.14. 22 divided by 7 is when you do long division. 22 goes inside the house, so 22 over 7. So 22 divided by 7, and you would, start dividing, right? So 7 doesn't go into 2, but 7 goes into 22 3 times. 7 times 3 is 21. 1 left over, and then you start adding 0, and then you keep going. 7 goes into 10 1 time. 7 times 1 is 7. And then your 3, and keep going. 7 goes into that 4 times. 7 times 4 is 28, and you can keep going. And this is what would be called rational. And they call that, this happens to be pi 22 over 7. Rational because there's actually more decimals in this. It actually continues. This is a never-ending long division problem. It's infinite. There will never be a pattern. These numbers will always be different. No pattern. That's a never-ending long division problem. But that's what they mean by infinite and non-repeating. That's an example. One example of rational. Another number that's irrational is E. E is on your calculator, and you'll see that if you have to take college algebra. E is another transcendental number, and it's on here. There it is right there. See that e to the x in green? See, it's green. So I do this second button, e to the x, and I can make that different exponents. But if I just hit the first power, see, this is infinite. They say there's no pattern. So 7, 1, 8. 2, 8, 1, 8, 2, 8, and it keeps going, goes going. So it does look like it has a lot of 8s in it, but that's a infinite and it's non-repeating decimal. Those are 2 examples of irrational numbers. These are irrational. I put rational. It's irrational numbers. Okay. So a number is either rational or irrational. So where this is infinite and non-repeating, for us, rational would, let's think. I think what I can put here to add for rational as far as decimals, because sometimes you are going to have some decimals there, but for rational, I can also add for rational, I can add terminating. You know how sometimes when you do long division, you get a terminating decimal? Terminating, if you get a decimal and you do long division, it terminates, it ends with a remainder of 0, and you get a decimal, it terminates. That's considered rational. And also repeating. Sometimes you do long division and you get repeating decimals, like 27, 27, 27, 27, or 1, 2, or point 125, point 125, 125, 125, 125. Those are repeating decimals. So those would be considered rational numbers. Whereas if you have something that's non-repeating, it's a decimal, but it keeps going and going, that's irrational. So I think that would be helpful. But for us, 15 is just, it's going to be rational, you know, because if you think about it, if you think about the long division, 15 is equal to 15 over 1, right? There's a little measuring 1. So when you do 15 divided by 1, 1 goes into 1 one time, times 1 is 1, 0, bring down to 5. 1 goes into 5 times, 1 times 5 is 5. See how it terminates? So you can think of it as you do your long division, it terminates. So you can kind of think of it as it terminates. So that it's rational. If I have to choose between rational and irrational, 15 is more rational, okay? And then also, even though it stops there, there is another vocabulary word. There's two. There's a real numbers right there and complex numbers. So a number is either real or complex. So all of these up here are considered real. And then you have separate complex numbers. Complex is separate. Complex numbers have the imaginary number, a plus bi. It's the real part and then the imaginary part. And if you're a STEM major and you have to take intermediate algebra and you take pre-cal, you'll be working in intermediate algebra and pre-cal with complex numbers, which has the I, the imaginary part, a plus bi part. So anytime a number has I, like an example would be 2i, that's called a complex number. And a number would be like 5 minus 4i, that's a complex number. Or if I say like 6 plus 3i, that's a those are examples of, this isn't complex numbers. Complex numbers are plotted on a grid that looks like this. A polar coordinate, like you take a pre-cal polar coordinate. So complex numbers are plotted on a polar coordinate grid, whereas real numbers are plotted either on a number line. Real numbers are either plotted on a number line, or real numbers can be plotted on a Cartesian coordinate plane. René Descartes, we're going to do graphing on test 3, a Cartesian coordinate plane, where you have like an x-axis and a y-axis. And so real numbers can be plotted on a real number line, or a Cartesian coordinate plane, rectangular Cartesian coordinate plane. Whereas complex numbers are plotted on a grid like that, okay? So anytime you have a number that has an I, it's complex, it's imaginary. And so going back to 15, numbers, just like numbers are either rational or irrational, but never both. numbers are either rational or irrational, but they're both. Well, numbers are either real or complex, but never both. So if I have to say, well, is 15 a real number? Or it's a complex number. It's not complex because 15 doesn't have an I. So it's got to be real. So 15, the other one that's missing, there should be an F and a G here. F would be real number, which 15 is, and G would be complex number, which it's not. Because complex number, you would need the I in it, and 15 doesn't have that. So just FYI, it's missing. There should have been another choice there that you should know about. Okay, and if I check 18 on the answer key, 18 says it's rational, which we said. It's integer, it's whole, it's natural, and then it's also real. You need to have real. So the book is deficient. I should let the publishers know to add that in there. Okay, it's 18. Okay, now let's go to, so you see on your template, how I have that there, 18, see? And see formula area, see how similar that is? Okay, 19, what's coming up is an absolute value equation. Find the real numbers that satisfy the equation below. Okay, so I have on those papers there, this page that says XXIVs, that's 10, 10, and that's actually 4. 5 minus 1 is 4. So that's Roman numeral 24. Equations and inequalities. Equations and inequalities. So you go down right here. See this part here? Absolute value equation. Absolute value equations right there. And it says for statements 1 and 2, the C would have to be greater than 0. Okay. But if you look at this, see, absolute value x equals negative 35.3. So that one is not on here because this is C, but it said that for 1 and 2, C has to be greater than 0. So this is your C, and this would have to be greater than 0. So the reason why this is a negative, this is a special case. And that one, I have to write that one in because I don't see that in here. There is a special case that's missing. So the special case would be that I'm going to call this maybe, I wonder if I can call that a 5 because it's 1, 2, 3, 4. Absolute value of x equals maybe a negative C. And that's actually tied to the definition of absolute value. If I go back to this page here, see this absolute value? Absolute value is the distance a real number, A is from 0, the distance from 0 on a real number line. So remember I said, like, here you are with a ruler, right, measuring distance. Okay, so the absolute value of a real number measures distance. So distance can never be negative. Distance is not negative. So here, when you have absolute value of x equals a negative C, a negative number, that cannot happen. This would be a no solution. And the reason for that is because of this definition that the distance a real number is A is from 0. This is because the absolute value of a real number can never be a negative. Okay, and that's because distance cannot be a negative, cannot be negative. Distance cannot be. You're never going to see a ruler. Nobody's ruler is going to have negatives on there. Distance cannot be negative. So to say this is absolute value, this is absolute value of x, absolute value equations, how could it ever equal a negative? It can't. There is no solution because the absolute value of a real number can never be a negative. Distance cannot be negative. So there is no solution for that. So that's what we want to say for this problem here. See, that's one of the choices, no solution. And if I check that, number 19, let me check my answer key. B19, no solution. See that? No solution. Okay, and that's because absolute value of a real number cannot be negative because distance can. Okay. Now later on the last page of the review, we will come back to this because this is one of our problems coming up. I think it's number 24. We will come back to this and then use that for this. When C is greater than 0, the absolute value of C when it's greater than 0 can be C or its opposite. C or its opposite, C or negative C. So we hold that thought and we'll come back, but that's like on number 24, I think. Okay. Okay, 20, evaluate the following expressions. Okay, so this is just more practice on PEMDAS. Please excuse my dear Aunt Sally, which is order of operations. Okay, so we don't have anything in P, no operations inside grouping symbols. We don't have any E, we don't have any exponents, no absolute values, no perfect roots. But we do have MD, multiplying and dividing, but we've got to do it from left to right, whichever comes first. So which ones comes first? Let's see. So you're eyeballing this, division and times, and whichever comes first. So this is first. 4 divided by 2. 4 divided by 2 is 2. So now this becomes 2 minus 2 minus 2 times 2. So we did this first. That comes first. 4 divided by 2 is 2. And now you're going to do that next times. So now we're gonna do that. We're still in MD. We're still in MD, but now times. So 2 times 2 is 4. And now we're doing subtraction. Now we're doing subtraction. 2 minus 4. You don't have enough. You're shy. So this is rule number, is it 3? Sign numbers. Let me go back to your rules. Where's that page that has your rule? Rule number 3, subtracting 2 sign numbers. So you're subtracting, you don't have enough. If you have 2, how can you give away 4? So that's rule number 3. So that's keep, change to plus, take opposite. So 2 plus negative 4. Okay, and then that's rule number 2. Rule number 2 is adding two sign numbers with different signs. Okay, so you take the absolute value of 2, which is 2. Take the absolute value of -4, which is 4. See, finally we get an LAV. This is LAV, which is the largest absolute value. So finally, it's not always on the top. I know the 3 times we saw was on the top. Finally, it's on the bottom. But see, that's negative. So it's going to be a negative result. So this is going to be a negative result. And then you're going to subtract. You're going to subtract both of these. So you're going to subtract 4 minus 2, which is 2, but it's going to be a -2. So that should be a -2. So we've got 20. 20. -2. Okay, and 21, more PEMDAS. This time you want to do the P operations inside parentheses. So A plus 1 is 9. And then you're going to do the E. So exponents. So now you have 9 squared. 9 squared means 9 times 9, which is 81. So now you have 6 times 2 minus 81. So we did the P, we did the E. So now you're doing, you don't have MD, you don't have D, but you have the M. Now we do M. So you're going to multiply 6 times 2 is 12. 12 minus 81. And now you have adding and subtracting. You have the subtraction, the minus. This is rule number 3. Rule number 3, we come back over here. Rule number 3, 12 minus 81. Rule number 3, which is subtracting sign numbers. Rule number 3, subtracting two sign numbers. See the subtraction? You have 12. You cannot give away 81. So keep, change, take the opposite. Keep, change, and then the opposite of 81, take the opposite, OPP, opposite of 81 is -81. And now that becomes a rule number 2. Rule number 2 is you're adding two numbers with different signs. So you're going to take the absolute value of 12, which is 12, absolute value of -81, which is 81. And see, this is the larger absolute value. So when you backtrack, see how it's negative? So you're going to keep the negative. Just like this one was negative, this one we had to keep the negative. Well, same thing here. Keep the negative. And then you're going to subtract these two. So 81 take away 12. So that's 11 and 7. 11 take away 2 is 9. 7 take away 1 is 6. I'm going to double check that. 81 minus 12 is 69. So it's a -69. No, 21. Yep, -69. Okay. So you might, if I went too fast on that, you can stop the video and go back and rewind it if I went too fast on that. Okay. But you see how we're using our rules, right? I'm using the rules, sign number rules. Okay. Round the following whole number to the nearest 100. Include, see the approximately equal to symbol on your paper. Okay, so from your co-read class, this is Roman numeral 10, page 10, place value chart. See your place value chart? You want to round to nearest 100. So this side is a decimal side, the small side, and this side, you have ones, tens, hundreds. Ones, tens, hundreds, okay? So we never put commas on this small side. We only put commas here, 1, 2, 3, comma, 1, 2, 3, comma, 1, 2, 3, comma, okay? These are like the natural numbers. And commas are required if you have at least 5 digits. If you have at least 5 digits, you want to put a comma. That came out on a Jeopardy problem time. Okay, so this is ones, tens, hundreds. Ones, tens, hundreds right here. So 9, 1, 8, 2, ones, tens, hundreds. So you should box the digit and then look at the neighbor to the right. And you ask yourself, is the neighbor, which is 8, at least 5? And you would say yes. So because the neighbor 8 is at least 5, that means you're going to increase the box digit. So not the neighbor, but the box digit, the number in the hundreds place. So you're going to increase it by 1. And 1 and 1 is 2, and then this stays 9. And then these become zeros. So the digits thereafter become a 0. Okay. And then you put the approximately equal to symbol. That's approximately equal to symbol on your paper. Okay. So if I check that, number 22, there it is, see? Okay. So if the answer had been no, if the neighbor is a neighbor 8 at least 5, we said yes. And so then if it is, and you increase the box digit, by 1. Always, if you do increase it, it's always increased by 1, and we did that. But if the answer had been no, then what would happen is this would stay the same. If you don't increase it by 1, it stays the same. So that would have stayed at 1. Okay. All right. Okay. Select the symbol. Okay, so is this number negative 5.9? Is this number less than this? Or is negative 5.9 greater than this? Or is negative 5.9 equal to? So this symbol, this is less than. This is greater than. And of course, this is equal to. So when you compare, you always compare the first number. Is the first number less than the second number? Is the first number greater than the second number? Or is the first number equal to the second number? That's how you always compare that. So here, when you show your work, you should draw a number line. And I guess I can put 0 closer on this side. So -1, -2, -3, -4, -5, -6. So -2.8 is close to -3, right? So this would be -2.5. So this is about right there, right? -2.8. And then -5.9 is close to -6. Okay. And remember, only on the negative side, okay, remember on the negative side of the number line, then numbers closer to 0 are larger. Or you can say on the negative side of a number line, then numbers farther from 0 are smaller. You can also say that if you wanted to. On the negative side of a number line, then numbers farther away from 0 are smaller. So whichever logic you like. But the main thing is when I look at this negative 2.8, this is considered larger because it's closer to 0. This is farther away. This is considered smaller. So then when I go to this, we're saying negative 5.9 is what in comparison to negative 2.8? Negative 5.9 is smaller than the negative 2.8. So the symbol for smaller is that. And then when I double check that on my paper, 23% symbol there. So your work would be a plot. You're expected, you need to show some kind of work for your results. So your work would be, I would expect a plot for that. The work that we show is you boxing the number in the hundreds place and show me your arrow, the neighbor. Okay, this is, if you're carrying, this is showing your work. So you don't have to write these sentences here, but this is your work, the boxing, the arrow, the +1, approximately equal to, okay? And I think I have that on the template. On the template, let me see. So this is template. I put like, include the approximately equal to symbol on there. Okay, and then I think we're coming up to this. Remember we said we're going to go back to the absolute value. So that's, we have 2 last problems. And then we're done. Hope this was helpful. What, let's see. What I'll do is I'll go to a copy machine and make a PDF of this. Well, actually, I have a scanner here. I can do it here. I have a scanner in my office, so I'll make a scan of it, make a PDF of it, and then I'll include that. And I'll also include these papers in there, but it might have an extra side that we didn't look at. Like this one, we use this side, but not this side. But I think it's going to double side it anyway. But I'll include all the papers that I use from your workbook, so you can reference that when you look at that. And then I'll put it in a page. I'll put in a page. I'll make a separate page. I don't know where to put it. I'll probably put a separate page because I'm going to have to put the YouTube. Well, it's going to be a Zoom video. I think I have 180 days to make it into a YouTube video. So I can use a Zoom for now and then change it later before it expires. But I'll put a separate page maybe that has it. That way you can kind of easily see that and look at that, reference it. Okay, so here, find the real numbers that satisfy this equation. This is an absolute value equation. Absolute value of x equals 39. So you want to go here to this Roman numeral 24, equations and inequalities. And you want to go down here to absolute value equations and see for statements 1 and 2, where C is greater than 0. That's what we have. This is your C. Absolute value of x equals C. See, where C is greater than 0. See 39. So that would not be an example of this. This is where C is negative, but we have 39. C is greater. So that's this. So if x equals C and C is greater than 0, then x equals C or x equals negative C. Okay. And although 2 is true also, but we don't look at this. We don't have this. We have this. So ours looks more like 1 as opposed to 2. So we have the number and its opposite, C and its opposite. So this is answer is the number and its opposite. The number and its opposite. And so we have 39 and its opposite. So we're going to use that, absolute value x equals C implies x equals C or x equals negative C. So answer is the number or its opposite. So I better use or, like I have and, I better keep it to or, like or. And so we have two solutions. This is what we have. We have 39, and then its opposite, which is negative 39. And as a check, if I take the absolute value of 39, and if I take the absolute value of negative 39, absolute value of 39 and the absolute value of negative 39, absolute value of 39 is 39, and the absolute value of negative 39 is 39. So you see how that checks out? You want to get 39, and these give us 39. So what x, see the x, where x works, absolute value of x equals 39. X can be 39 and x can be negative 39, and it gives you a true statement. Okay. So what you can do to support your work, like to show your work, you can like write this down on your, and you can use this to study. When you take your test to jog your memory, you can have these notes out to study, and the numbers are going to be different. Like you're not going to have 39, it's going to give you a different number on there, but you can write this just short, show your work to support that. 25, use the definition of an, oh, was I going to check? I got to check the answer, right? So 24, two solutions, 39 or negative 39. Okay. Okay. Use a definition of an exponent to write the given product in exponential form. Okay. So you have all of these here. So if any of them repeat, you want to use an exponent. So 11 shows up twice. 11 shows up twice. So that's why we can say 11 squared. Oh no, 11 shows up thrice, which means 3 times. 1, 2, 3. And 5 shows up twice. So see, these are like little dots here, right? And then 3. So I guess I can circle the 5s. And then I can make, I guess, triangles. 3 shows up 3 times. Okay. Okay, so if I double check, and I don't think the order matters. I think the order matters. So 3 cubed, 5 squared, and 11. So it's a little bit out of order, but it's okay. I think they put it from smallest to largest, right? The bases are smallest, small base 3, 5, 11. I think they're putting it in order from bases. So I guess, I don't think it really matters because multiplication is commutative, but I think this would be okay. Or I think they're putting it like smaller, base of 3, base of 5, base of 3. So these are called bases. And then these are called exponents. Okay, all right. And so what I'll do is I will, so what I will do is I'll make a PDF of all these pages, and I'll include extra pages that we use from the workbooks in there. And that way you can use that to study. And then this is 5 points. You get rewarded for looking at the video or checking your work, either using the detailed PDF or the video. And you can use this while you take the test to jog your memory. And I hope you do well. The test is very similar, just the numbers change. And I encourage you, I think students do better if they print the template. So, and I think this is 80 minutes, but you really have 100 minutes. So there should be 100 minutes on there. Just fix that. So I'm going to say, I hope you do well on your test and study well on your test. In order to take the test, you have to have your acceptable sitting position. You have to have these homeworks done. You have to have the certified homeworks done for 6.3 and 6.2 and all of chapter 8. And then be sure you're uploading your work from your certified practice into the relevant assignments. This, when you submit this, this goes into 410. So your test work and your final exam work and your reviews, test reviews go into Math 410 Canvas course. When you take your quizzes and your quiz reviews from your study guide, those go into Math 105. That's where those get uploaded. And every time you launch a test, you launch it with Respondas. You show your little picture ID, hold it up for about 9 seconds, and you do the environment check. You show putting your phone into a backpack and putting it away. You have the acceptable setting position. So I sometimes have a box. I'm just going to show you this box here. So for the acceptable sitting position, I'm just using this because my computer is elevated. I have it on 2 books, but I need this, this view from you. I need this view of you from your desktop or tabletop working. So sometimes people get a TV tray or they have 2 tables, get that distance. But then you need like a mouse or a wireless mouse because you don't be stretching like that. Or you just, you angle yourself diagonally, at your table, diagonally your computer, so you have that distance where I can see that. But like right now, this right now is not acceptable. See, I can't see the desk. I can't see the desk work area. So maybe if I see, my computer is too elevated because it's like I have like 3 calculus books that's elevated on. But this is not acceptable sitting position because I can't see what's writing on that desktop. So you do need to fix it so that I have that view from you, okay? All right, so good luck with your studying, and I will put this video up for you to do that, to study, okay? Take care. But mind on math.